All right, welcome back to Principles of Engineering. We're going to go over screws today. I've got this problem up on the board. A vise has a 5/8 screw and a handle 5 inches long. How much force is developed between the jaws of the vise when a force of 40 pounds is applied to the end of the handle? I need you to draw and annotate the forces, to calculate the IMA, the ideal mechanical advantage, and then calculate the AMA, the actual mechanical advantage of this vise if the efficiency is 60%. So to start off with, we're going to, of course, draw and annotate the forces. But if we don't know what some of the terminology is here in this problem, we need to find out and understand. So I know some people taking this class don't understand what a vise is, so I want to just show you. A vise is a mechanical device. Here's a woodworking vise. This would get mounted onto a wood workbench, and of course it's got a screw. You've got a fixed jaw, and you've got a movable jaw on the woodworking vise. This is one style vise. Another style of vise is what's more commonly seen in different workshops. This is just your simple metal working vise, a little bit stronger. Again, you've got a screw, and it's that rotational motion of the screw that generates the linear motion of the vise. Again, we got a fixed jaw and a movable jaw on that vise. So we're going to calculate out some of the forces that are going to be applied on that. But first, we're going to draw and annotate the vise. So up here, I'm going to kind of draw what's simple. Again, I said we got a fixed jaw, usually looks something like this. So, and this is my jaw over here. This is my base, and then I got my movable jaw, kind of slides back and forth on this, so we get a little friction under there. Generally comes either underneath the vise or right in through here, where you can kind of have some support for the ball screw there as well. So for clarity's sake right now, I'm just going to draw my screw attached coming through here. So we'll have a screw under here that's going there, and at the end of that screw I got a handle that is going to get turned. We'll put like a little knob on the end of that handle, and we've got some information that we need to put out. So we got a 5/8 screw. So our screw right here is 5/8, so we know that. All right, and we've got some forces. We also know that the handle is 5 inches long, so we'll put that over here, right, that is 5 inches. So with 5-inch handle. Now let's write out and apply all of our forces here for these calculations. So we're going to have an FR, a DR, and FE, and a DE that we all have to figure out what these are. So the first thing we're going to see, we've got a force of 40 pounds applied to the end of the handle. So that is the force of our effort. That's our effort force. And we want to see what our resistance force there is going to be when we calculate this out. Now, be careful with this problem, because I got a couple of things in here that you don't really need to know, that are kind of there to trick you up just a little bit and make sure that you're thinking as you have on. So, but let's start out with the 5/8. There's some things that are missing with the 5/8 screw here that we're talking about. First off, let's start with, what is that 5/8? Well, that 5/8 is actually the diameter of the screw. So I'm going to mark this, annotate that, that is 5/8. And I'm going to use that diameter symbol, which is the circle with a slash that indicates 5/8. And we can put that 5/8 right there. So 5, that stands for 5 TPI, or threads per inch. So this is 5 threads per inch. So what we are missing here is the actual length of the screw. And in the case of this vise, I don't for this problem, I don't really need to worry about the length of the screw. Of course, in reality, when we're talking about our vices, the length of that screw is going to determine how wide of a gap that we can space our movable jaw from our fixed jaw. So that's going to give us a depth or thickness so that we can put a workpiece in there and clamp depending on the length of the screw. But for calculation purposes here right now, we don't really need that length of the screw on this one. But we do need to know something about the 5 threads per inch. And what we need to know there is called the pitch. So, and if you remember from the PowerPoint display, pitch is 1 over threads per inch. Now that 1 is actually a 1 inch, so 1 over threads per inch. So we can calculate our pitch right away. 1 divided by 5 is 0.200 thousandths. So 200 thousandths of an inch is the pitch for this. Now that has a couple of different meanings and we're going to figure. So that really is between the center of our screw thread. That means that spacing from here to here, this is the pitch, and that's going to equal 200 thousandths. That spacing between those threads is 200 thousandths of an inch, 0.200. So there's our vise. Obviously the movement here on our movable jaw, it can be moving either way, and we're going to apply a force on that. But first thing that we got to do is to calculate the IMI. I've drawn my stuff up here. I need to calculate my IMI. Now, I don't have the distance of my resistance or distance of my effort at this point, so I can't use that. We got to remember what our IMI is in regard to screws. So, and that's our IMI for screws is a little bit different from our IMI for our levers or our wheels and axles. So we got to make a decision. And if you remember, again, going back to the PowerPoint, the IMA is our circumference divided by the pitch. Now, we know what our pitch is. The question I'm going to ask here is, what's the circumference that I'm using? So we've got 2 sizes that would give us a circumference. The one size, of course, would be the 5 inches here on our handle if we were rotating that handle all the way around. The other size is the 5/8 diameter of the screw itself. So the circumference that we want to use in this case is actually the diameter of the screw itself. So we need to use 5/8 diameter there. And if you remember, circumference is just pi times the diameter over the pitch to determine our IMA. So we got pi times 5/8 of an inch over, we already calculated our pitch to be 0.200. So let me grab my calculator real quick, and we will see that pi times 0.625, which is 5/8, is 1.963 divided by 0.2. So, and we get an IMA of 9.817. So we have our IMA here equals 9.817. Now the next part of this problem is asking us to calculate the AMA if the efficiency of the vise is 60%. So now we've got to remember, what's the efficiency formula? Well, my efficiency formula, as I go over here, efficiency equals the AMA over IMA times 100 to give me that percentage. So plugging things back in, I want 60% efficiency equals, AMA is what I'm looking for here. My IMA I already saw to be 9.817, and this is times 100. So we can real quick go back, we divide both sides, we find out that this becomes 0.6 and times 9.817 is going to give us our AMA. And again, if you're not familiar, if you don't remember how to do the algebra to get to that point, see me so we can talk about it. I just take 9.817 times 0.6 and I get an AMA of 5.890. So my actual mechanical advantage here is 5.890. All right, so that gives us the answer to these, but we also need to know how much force is developed between the jaws of the vise when a force of 40 pounds is applied to it. So if you remember, our AMA equals force of the resistance divided by force of the effort. So let's plug in 5.890 AMA. That equals, we already determined, our effort force, force of the resistance, divided by 40 pounds, which is our effort force. Now, the force of the resistance that we can put on here to hold that part in place then becomes 5.89 times 40 pounds, or 235.6 pounds that we can exert as work holding power to hold and clamp that part into place when we crank that handle. Now, I also want to point out real quick, is this vise actually a simple machine or is it a complex machine in reality? Simple machines would only have one. In the actual use of this vise, we have both the screw and the lever. So in reality, we have a complex machine here with both the screw and a lever being applied. So we could take this a lot farther with the fact that this is a 5-inch handle and calculate out our mechanical advantage for a complex machine in this case, which is what we would eventually looking forward to doing. But for today, I just wanted to concentrate on the simple machine of the screw. We can really disallow and not even worry about that 5-inch because all the information we needed was right up here in this 5/8 inch diameter and the 5 pitch to determine the mechanical advantage of a screw. So thanks for watching. Hope this helps clear some stuff up for you.